Dr D Dhanasekaran. So I am working as an associate professor in the Department of Mechanical Engineering at Ahmed University. So my specialization is turbo machine. Today we will discuss about the basic introduction of computational fluid dynamics. So before going to see the other things, first we will see that what is the definition of computational fluid dynamics. Computational fluid dynamics is a technique which is used to predict the behavior of any system which involves fluid flow as well as heat transfer. I will repeat once again, computational fluid dynamics is a mathematical technique or numerical technique which is used to predict the behavior of any system which involves fluid flow as well as heat transfer. It indicates any engineering system. Say for example, an IC engine is a system, a pump is a system, a marine turbo machines is a system, marine propeller is a system. So all these engineering system involves either fluid flow or heat transfer. So this computational fluid dynamic technique can be used to analyze these kind of systems. So what are the basic steps of this computational fluid dynamics? This computational fluid dynamics involves three major categories. It has one pre-processing stage and solver stage, then post-processing stage. So these are the three stages. In pre-processing stage, so we have to create a system. Then we have to assign system properties and what kind of fluid flow, all the basic information, fluid flow properties and its geometric properties, all those things has to be incorporated into the pre-processing stage. In solver stage, certain set of mathematical equations will be solved to analyze the problem. So once solver stage is over, then all the data will be transferred into post-processing stage. In the post-processing stage, we can analyze the behavior of these systems. So these are the basic three steps involved in the computational fluid dynamics. And what are the applications of this computational fluid dynamics? Nearly all engineering field we can use this kind of CFD technique. Say for example, civil engineering, mechanical engineering, even aerospace engineering, automobile engineering, marine engineering, even electrical engineering, environmental engineering, biomedical engineering. Nearly all engineering discipline we can use these kind of CFD techniques. So why we need these CFD techniques? What necessitate this computational fluid dynamics to be incorporated in all engineering system? Yes, basically in industries, first a component is designed, then a small prototype of this component will be created. Then this small prototype component will be tested in the laboratory. Once the test or experimentation is over, certain parameters have been extracted from the experiment. Then based on the parameter, the performance of the system will be analyzed. If the performance of the system is not met certain standard, again the design will be changed. So these are the design cycle incorporated in nearly all the industries. But here, during the prototype creation stage and the experimentation stage, certain disadvantages are there. That means to create an experimental setup, we need more money, we need space, we need equipments and we need manpower. So this will consume more time. So in order to reduce time and to complement the experimentation process, CFD techniques are introduced. So CFD techniques, definitely it will not replace experimental method, but it will help the experimental method to enhance the product design. So quickly in the design stage itself, we can create a 3D model, then we can bring the 3D model into CFD process, then we can assign all the property, then we can solve, then we can do post-processing and analyze all the design criteria. And in the design stage itself, any modifications are required, we can modify the component rather than going for any modification at the end of experimentation stage. By adopting CFD technique, the design stage itself we can do any modification, so which saves manpower, money, time. So these are the main advantages of the CFD. Then how can we incorporate CFD in the real world? Yes, there are certain mathematical softwares are available. Say for example, in market several CFD softwares are available. How these softwares are working? These software need first a 3D model to be created. Then those model has to be generated by using mesh. Mesh we have to create it. That means grid generation we have to do. Then in the grid generation, after grid generation, we have to give all the fluid property, flow property, geometrical property, everything we have to set, and mathematical model we have to set. Then the set of equations, set of governing equations will be solved. Then at the end, the result will be transformed into post-processor. In the post-processor, we can visualize the fluid flow or heat transfer phenomena. Then based on that, we can change any design modifications. So these are some fundamental aspects of computational fluid dynamics. Thank you very much.